настроение.
Кто заедешь в гости так-то, что поздравить 8 марта?
От меня прими подарок, меня поцелуем жарко.
Только их тебе не жалко, я твоя фиалка. От того, что знаю, у тебя другая, а я запасная. Знаю, от того, что знаю, у тебя другая, а я запасная.
Заскочил на часик.
Specify procedures of script. On the more assembly machines, we notice the importance of the cartoon chart. The cartoon chart is provided by SAM Automation Company. For the PLC control in CMS CAPP, we use K20 and cross the PLC by K21. For the actually PLC Y various control, suppose like K20 Y11, open Y11s will let the relative relays works and control the piston, the cylinder, to push the components out. For the script of CMS CAPP, we use K26 to move the objects a distance. The object's number on purpose the same as the value of the Y. Suppose the Y11, the driven object is object 11. So according to the cartoon chart, and the Y11 driven object 11 and the driven distance in S, Y or Z direction is very clear to write down the procedure step instructions in CMS CAPP. So the cartoon charts is very important for teaching to write the visual script. But the procedure of the actions, we still think the cartoon charts is not enough. We still has to specify the procedure of actions. We strongly suggest a specification of the procedures method. We adopt education builder of Taiwan, Republic of China, which is provided by Dr. Zhang Yuming, Zhang Bo. Okay, before speaking this lecture, suggest to go to our website www.cmschiao.com, to our company's website, and there you can see 1, 2, 3, 4 in 4 technical support, and you can see 操作说明动作流程规定1 649.95 94 kbytes, launched at 2018 December 11th. Press this one, download, and unpress it. You will get a file folder named Automatic Procedures SOP 1, and open the file folder. You will get 4 files, 2 in Chinese, 2 in English. This is the first test of B class. Testing topic, and open the vibrating payoff and the quality inspection station. Inspect stations. You will see assembly, decomposing, join. This is assembly, join. This is decomposing, join of B class electromechanical integration verification facilities. This is the topic number 1, vibrating payoff and quality inspect stations. This is the whole machines look like, and this is decomposing joints. The base plate in here, the vibrating payoff in here, 3 feed slope in here, and 4 swing wet and transfer pneumatic cylinder. In here, and 5 testing seats and position watt, and 6 rotating descending watt and potential meter in here, and 7 conveyor and loading watt conveyor in here, and outlet hiding there, and solenoid valve, numerical valve, interface terminal, and the wrong parts. This is just outlookings of the testing facility. We intend to introduce is the standard specification, the procedures of the script, combined together with carton charts to write and edit the visual script by using CMS CAPP. The topic vibrating payoff and quality inspect sketch of mechanism. I hope before doing any Visual Script edit, it is better to draw this 3D mechanism in detail. You can see in here A, vibrating payoff, the B, shifting piston, C, swaying watt, D, vacuum sucker, E, inspect watt, F, watt of return material, G, conveyor, H and I, straight in rotating watt, and the sensor S10 potential meter, S11 sensor, S7, S8, S9 inspect seats sensor, S2 for error limit, S3 for middle vertical limit, S4 right limit switch, and the sensor S5 and S6 is for the shifted piston to move up and down, and S1 material sensor. The drawing is in this way is quite clear. Actually, procedures for this testing is the round piece in vibrating payoff machine will coming down along the slope in sequence. The S1 material sensor sense the material down. The swing rod will turn clockwise to these positions. By controlled on touch of S4 right limit switch will stop in position, and the D vacuum suckers will suck the round bar, round parts, and then turn counterclockwise to touch the left limits to this position, and release the piece in here and turn back to the center vertical position. Then the inspect wet will move down. This one will press the round bar in the position. The sensor will sense if the position is here, the diameter of the round bar is too short. If on these positions the round bar's diameters is too big, if in these positions the diameter is okay, after check the diameter, the watt of return materials will push up. The potential meters will report the potential in between. The analog signal of the potential will be translated into digital values. The digital value can tell the thickness, actually the height of the round bar. If the height within a specified accuracy value, then we can accept this component as qualified OK. Otherwise, the height is unqualified. After that, the inspection valve retrieve back to the high positions, and then the swing valve turning counterclockwise on top of the inspected parts and suck the parts to the vertical positions. And in that moment, the shift piston push the cylinder to let the whole facilities to go to this way. Then the swing valve turning clockwise to these positions and release the parts and go back to the vertical positions, and the shift piston return back to its home position. And as S12 sensor sense materials in positions, the conveyor will start to run. Take the material, the parts, go to the position in front of straight in rotation valve H. If the diameter unqualified, the H will be actuated and press the outside diameter unqualified parts to go through the channel to this position. If the diameter okay, then the parts will go to the H, the I positions. If the parts height unqualified, the H, the I straight in rotating valve will be actuated and push the high unqualified parts to this channel. If the parts diameter and height all be good, then we'll go through this outlet sensor S13 and collect in the terminal. This is why I'm speaking. But for the standard requirements, we need a statement of action. 3 requirements. The first one is machine origin. The second is the manual function works. The third is the main parts, is automatic functions. The procedures has to be stated clearly. For the machine origin is as a vibrating pair of machines switch on. The B shift piston at the rear positions. That is the home position of the shift piston. The D vacuum sucker not work. The C swing watt let the vacuum sucker D stop at vertical positions. So at the home positions, this bar should be vertical located. And the E inspect valve at the top position. Inspect valve at the top positions, at the top, to keep space as the swing valve turning to here, not bump with the potential meter. F watt of return material at the low positions. This one at the low positions. And the conveyor stop. HI straight in rotating valve at the low positions. And here. The high positions, this one will move to there to kick the material to this channel. Okay, this is home original situations. You have to write down clearly. And then the second, the manual function works to make sure the capability of a control panel can activate each actor A to I, H, G, E, F. The A is this one. B, C, D, E, F, G, H, I. Everyone can handle it manually. Suppose in these situations, let's reset, stop the PLC function. In I/O modes, for each one, Y1 to Y12, the Y can let the PLC push the relative relays and open the facility to move. Suppose in here, as we testing manually, for Y25 is control the vertical cylinder to lift the shifting mechanism. Okay, let's change to English I/O table for better looking. So Y25 aluminum pipe rice cylinder. So we can control this CAPP by control manually. As we press Y25, the light is out. The Y25 is actuated. You can see the machine beside you. If the vertical cylinders lift, if the vertical cylinder moved vertically, then we know the Y25 controlled by hand. Okay. And suppose we press this button, you can see Y24 button in red, and we can survey the aluminum pipe transfer cylinder, the horizontal cylinders move or not. If it moves, then the transfer mechanism will be moved along positive acceleration 50 millimeters. For everyone, you can push to survey the operation is okay or not. Okay, let's continue. So the manual testing is very important. Okay, let's see the automatic functions. The first, to put wrong parts in vibration payoff machine arbitrarily. Vibrating payoff machine pushing wrong parts up in wheels. The one with gap towards top will pass examination to be moved to slope. The others will drop back vibrating payoff machine. The one, okay, then will be sent to the slope one by one in sequence. The first one on top of the flat platform, waiting for moving. Second, C swing valve returning clockwise to slope. D suckers sucking parts. C swing valve turning counterclockwise to inspecting seats. D vacuum sucker putting down part. C swing valve return clockwise back to vertical position. The second procedure is to lower down the rod, turning clockwise to touch S4 sensor in positions on top of the round bar if the material sensor S1 on. And then the sucker, the I/O will be turned on to suck the round parts, and then the rod will turn counterclockwise to touch S2, the left sensor. As the left sensor on, the parts just in the positions in here, and the sucker off, leaving the wrong parts on the inspecting seat, and then turn clockwise to the vertical positions and stand by there. This is the action of step 2. Step 3. E inspect the rod moving to push parts downward. Sensor reporting out suitable pressure. Then stop. Using photoelectric sensor to get stop position to judge if the outer diameter qualified or not. F watt of return material moving up. Potential meter measure voltage at the top of wrong part via analog and digital converter to check the height. The analog is the value of the voltage. To check the height of wrong part qualified or not. E inspecting valve moving up. Okay, the step 3 is the step in here. The first inspect valve will lower down to press the wrong parts to a level. In here, in here, in here. If in here, the sense will say the diameter too big. So if press in here, okay, it's good diameters, qualified. If press down here, the outside diameter is too small, unqualified. After checking the outside diameter, the watt of return material will push up. The potentiometers will give a voltage to say the height of the parts is qualified or not. Depends on the voltage. The voltage via a AD converter to change to the digital report to the PLC. In CMS CAPP reports to computer. After that, the potentiometer will leap up. This is the step 3. The step 4, C swing watt returning clockwise to inspect seat. Vacuum sucker sucking parts. C swing watt returning clockwise back to vertical position. F watt of return material moving down. B shift position moving at the front position. C swing valve turning clockwise to conveyor. Vacuum sucker putting down part. C swing watt turning clockwise back to vertical position. B shift piston at the rear position. The step 4 saying the swing valve from vertical positions turning counterclockwise again to meet S2, the limits inclined in these positions. The sucker just on top of the inspected wrong parts, and with an IO on to suck the wrong parts, and then turning clockwise in to back to vertical position, and then shift the piston, push the whole mechanism forward to this position. In positions as the sense S6 on. The swimming watt, the rod of the swimming valve will turn clockwise as touch the limits just in these positions, and the sucker's IO will off to let go the wrong parts on the terminal of the conveyor, and then the rod turning back to vertical, and the shift piston turning back to home positions, and also the return valve materials return back to home position. Then the last step 5, as S12 the sensor become 1. There is materials on the terminal of conveyor. The conveyor turning, moving parts to the front of H straight in rotating valve. If outer diameter not qualified, H straight in rotating watt will reject the parts at the first outlet slope. If not reject on this H station, then the parts will be moving the parts to the front of I straight in rotating watt. If height not qualified, I straight in rotating watt will reject parts at the second outlet slope. At last, qualified parts moving to the end of the conveyor. Okay, the step 5 is if the sensor S12 has become 1, the material sensor notify there is a parts waiting for handled. The conveyor will stop to move the parts. As the parts moving in front of the H position, if the outside diameter unqualified, the H straight rotating watt will be actuated and reject the parts. To kick the parts rolling down the slope. If the outside diameter qualified, the parts can still moving suppose to the front of the cylinder I. If the height unqualified, the straight in rotating watt I will be actuated and kick the high unqualified parts rolling down the slope. If the heights still qualified, the parts will continue going to the front of the outlet sensor and collected at the terminal. So through these statements, the machine original, the manual functions, and the automatic function together with the cartoon charts, is very easy for the user of CMS CAPP to write, edit the visual script. So this is highly required by CMS CAPP to write down the standard specifications. Okay, the end of this lecture.